goes on the outside? What goes on the inside? Anything that I have to add into that one? Nope, got all the places? Okay. First needs to be x squared, right? Okay. So then we got 3x cubed minus 2x squared. That again was x squared times 3x minus 2. Okay. Then we do what? Change the signs. So that gives us 3x squared. Then what? Drop the plus x like it's hot. Then I need to multiply by something to get that, so that's going to be x. Three x squared minus 2x. Then what? Flip the signs. That gives me 3x. Then what? Drop the 2 like it's hot. Multiply by 1. Then flip the signs. Leaves me with a remainder of 0. Right? So this division here is x squared plus x plus 1. What do I know then about 3x minus 2? It's a factor of that big polynomial. Okay? It divides in evenly without a remainder. Okay? Long division. Using our long division techniques that we learned way back in 4th or 5th grade. Okay? What I'd like you to do now is in your textbooks, I'd like you to turn to page, this is number 2D on page 330. I think it's number 2D. Yeah. Yep, number 2D. Yep, on page 330. I'd like you to do it right now. Go. So 3x plus 2 goes on the outside. 9x to the 4th plus 3x cubed. So I'm following in order. Then I need a x squared term. I got that one. Then I need an x term. Then I need a constant term. So I got all my terms. Don't have to fill it in with any placeholders. Okay. So first I need this to be 3x cubed, because 3x cubed then times 3x plus 2 would give me 9x to the 4th plus 6x cubed. Change my signs. That gives me negative 3x cubed. Drop it. Multiply by negative 1x squared. That's going to be negative 3x cubed minus 2x squared. change the signs. That gives me 6x squared. And I drop the 7 like it's hot. Multiply by 2x. X squared plus 4x. Change the signs. Gives me 3x. Drop the 2. Multiply by positive 1. Change the signs, gives me a remainder of 0. So my answer here, can't fit it up top, so we'll go down here more, would be 3x cubed minus x squared plus 2x plus 1. And what else did we learn? 3x plus 2 is a factor of that big 9x to the 4th plus 3x cubed plus 4x squared plus 7x plus 2.
So why do you change the signs?
Subtraction. Yesterday when we were doing in numbers, we subtracted them. So to change the signs, we've got to subtract them both. So we change the signs and then we just straight up add them. Okay? Alright? What I'd like you to do now is we're going to do something a little different. Okay? It's on page 331, so it's the next page. Okay? We're going to skip number 3. We're going to go right to number 4, A and B. I'm going to give you approximately 5, 6, 7 minutes, somewhere in that range. I want you to individually, without talking, do A and B. Do 4A and 4B. Then I'm going to give you a moment to talk to somebody around you, to see, compare your answers, talk about how you did it, what you did. Then I'm going to give you another minute to go to the other side of the room and compare answers. Okay? With me? Okay? And then we'll come back and then I'll do it. Okay? So 5 to 7 minutes starts now. So how am I going to determine if 2x plus 1 is a factor of j of x?
Use long division.
Long division, okay? So then 2x plus 1 would go on the outside, and inside would be 2x cubed plus 3x squared plus 7x plus 5. Now, if 2x plus 1 is a factor, how am I going to know if it has a remainder or not? So how am I going to tell?
It's not going to be a factor. It has a remainder.
If there is a remainder, it's not a factor. If the remainder is 0, it is a factor. Okay? Alright, so I got to do this. Looks like x squared to start. So then x squared times 2x plus 1 is 2x cubed plus x squared. Switch and add. Then that gets me 2x squared. Drop. Multiply by x. X times 2x plus 1 gives me 2x squared plus x. Switch. Switch gives me 6x there. Drop the 5. multiplied by now here 3. Gives me 6x plus 3. Switch and switch. Leaves me with a remainder of 2. Yes? So this is 2x plus 1 is not a factor because, it said explain our reasoning, because there is a remainder of 2. Yeah. So that one is not a factor. Yeah? What about in part B? We're wondering again if 2x plus 1 is a factor. Did anybody get an answer? What do you got, Len?
So yes, it is.
Yes, it is. Why did you say it is?
Because if you say 2x plus 1 equals 0.
Okay. So first off, let's set 2x plus 1 equal to 0. And so then we get what? You sure? If I put 0.5 into that one, or 1/2, I get 2 equals 0. Right? Because don't you subtract 1 first? And then x is negative 1/2? Which is a huge difference than 1/2. Okay? So, logically speaking now, let's work backwards. If 2x plus 1 is a factor, right? Then what is the root, the 0, or the solution? If 2x plus 1 truly is the factor, what's the root, the 0, or the solution? Negative 1/2. If negative 1/2 is the root, the 0, or the solution, what is the x-intercept?
Negative 1/2 or negative 0, comma 1/2.
Nope.
Negative 1/2, comma 0.
Negative 1/2, comma 0. Which means what? Which means the function would have to cross through that point, right? Well, that point is right there. Does my function go through that point? No. So this is not 2x plus 1 is not a factor. Because if it was, it would have to go through the point negative 1/2, comma 0. It does not. Okay? Today you're going to get a green homework. It's going to be 4.2 day 2's homework. It will be due on Monday. All right, so looking at that first one, let's set up the first one on the homework so that we get it right. Okay, so we got 3x to the 5th plus 20x to the 4th minus 92x squared minus 60x, and then divide that by x minus 2. Okay, so x minus 2 is what goes on the outside, right? And then 3x to the 5th, then I need to have my x to the 4th. Well, that's 20x to the 4th. Then I need to have my x cubed. It's not in my original function, so I write in plus 0x cubed. Okay, got to have that placeholder. Then I got to have my x squared term. That's negative 92x squared. Then I got to have my x term. That's negative 60x. Then I got to have my constant term. So that one's plus 0 at the end. So in the first one, there are 2 placeholders that need to be put into it. Okay? Especially that last one. Because if you stop short, then you're still wrong. Okay? With me?
So you can never have a function that goes like 3, 1, and then 1, x and then 1. So you always have to have it.
Well, you can have it, but if you're dividing it, you got to put in the 0.
You gotta have it going.
You got to have them. So we started with here with 5. Then I got to have 4, 3, 2, 1, and nothing. Yep. Okay.